problems on the problem set, E and F are the most challenging because you haven't seen this integration technique before. But when you do see it, it's not going to frighten you anymore. What's the antiderivative of cosine x dx? No, just sine x, right? Plus c. What if you had cosine cubed x dx? What was our technique for doing that? What would we do with cosine cubed x? We'd split it into cosine squared and cosine x, right? And then we'd change that cosine squared into 1 minus sine squared. And then do you remember doing that? Okay. But what we didn't talk about is what if you have cosine squared x, right? And Max is probably ran into, oh, let's change it to sine, 1 minus sine squared. But that gets you into the same problem, right? So you're not going to have this, I don't think, on IB exams, but I've seen it many times on the IB exams. What did I just say? Well, they don't expect you to know it, but they expect you to be able to derive it. And so if you took cosine 2x as an identity, what's cosine 2x equal to? Cosine squared x minus sine squared x. Do you agree with that? Max, you good with that? So then I'm going to get rid of this sine squared. And so now cosine 2x is going to be equal to 2 cosine squared x minus 1. That was one of my alternate forms, right? This is kind of cool. You're going to like this. Solve for cosine x algebraically. So what's cosine 2x equal to, or what's cosine x equal to? Well, it's cosine 2x plus 1. And then now what do we do to solve for cosine squared x? Divide by 2. And so if we divide by 2, we get cosine squared x is equal to cosine 2x over 2 plus a half. Weird expression, but what do you notice about that? You could integrate that with u sub, yep. So we're going to replace this cosine squared with this, and sine squared, doing the same technique, is going to be, I believe it's 1 minus cosine 2x over 2. That's the substitution if you went the other way, solve for this one, 1 minus sine squared. Yeah. But don't worry about this right now. We're just doing this one. So we're going to replace cosine squared x with cosine 2x over 2 plus 1/2 dx. And now I can split this into 2. I can make this cosine 2x with a 1/2 out here plus integral of 1/2 dx. And if u is 2x, I'm going to need a 2 here and pull out a 1/2. So I'm going to get 1/4 sine 2x plus 1/2 x going from, what is it, 0 to pi over 4? Okay, and then now we're going to put those in. 1/4 sine 2 times pi over 4 plus 1/2 pi over 4 minus, now I'm going to put in a 0. 1/4 sine of 2 times 0 plus 1/2 0. Well, these will just go to 0, won't they? And what's the sine of pi over 2? What's the sine of pi over 2? Think unit circle, sine pi over 2. What's that? 1, yep. So this is going to be 1/4 plus pi over 8. That's what that answer is going to be. Is that what they had in the back? I think that's right. So the only difference between this one and this one is you're going to go 1/2 minus cosine 2x over 2 dx. I'm just so glad we got to do this one because this is really the last weird technique. Yeah. I think this is great. In IB, sometimes what they'll do is they'll say, put it in the form A plus pi over B form. Or they'll say A plus pi all over B form. You could do either of those, couldn't you? But if it doesn't, I'm fine with either one. If you got this far, holy cow. Terrific. Bam.